The tutorial, because some of you may have to leave and it's better that we start it. Use of fly ash as a road base in road construction and also environmental applications. So the fly ash in road structure, road-based construction, various waste products play vital roles. And waste products can be used as an alternative for conventional aggregates like soil, stone aggregate, stone chips, and cement in the embankment. And also, road construction things, they use other features like granular subbase GSB, water-bound macadam WBM, and these things are very expensive and have limited resources. So thus, nowadays, fly ash is also coming in practice, and it is proved that fly ash is not only easily available, but it shows better results than other waste products. So that makes fly ash a bit interesting. Now, as shown in an earlier lecture, even about 10 years ago, more than 1 million tons of fly ash, that is 3.4% of the total fly ash, was used as road subbase. Somehow the direct use of fly ash, is not possible because of its low strength. So, because there are so many ceramics, therefore fly ash may be stabilized through traditional soil stabilization agent like lime, chemical things, and also cement. So fly ash may need to be improved. Now, these stabilizers are very expensive also and inconvenient in handling with fly ash. So, often modern technique of reinforcement of pavement layers is introduced and is more effective and is simpler. Now, when you talk about reinforcement, it can be like strips, sheets, nets, mats, grids of metals and synthetic fibers. What happens if you put those things? It reduces tensile strain. That means it gives more flexibility and it reduces the fracture. So if you put these in the road things, there are lesser cracks. Often when you drive along roads or you walk along roads, unlike IIT Kanpur, as one of your friends said that in IIT Kanpur, they don't allow many buses and motor cars to go through, which is very good. So I don't see much of cracks on the road surface. But whenever you go to heavy roads, there are often cracks on the road surfaces. And it's not always easy to manufacture, just modify the cracks or cure the cracks, because then you have to actually close the road down and things like that. So if you can reduce the tensile strain, then the road will not crack, surface or downstairs will not crack quickly. Now, when you talk about composites, a range of fibers are used, and these ranges of fibers are, for example, aramid, which is Kevlar, is a plastic fly ash, and it has molecular melting temperature about 250 degrees C. Then you can also have ultra high molecular weight polyethylene, it's known as Spectra or Dyneema, and it has because being a polyethylene, its molecular weight very long, so it's quite strong, but its still melting point is around 120 degrees C. Then boron is another fiber, it's ceramic fiber. Now boron and other ceramic fiber can be small in size or you can have large in size. But small sizes are easy to handle, so you can put there because they are strong. So boron and other ceramics can also be used. And subsequently, natural fibers and natural material derived matrices, they can also be used. There's lots of natural fiber like vegetables and also cane fibers and things like that. They can also be used. So natural materials, matrices device, these things can all be used as fibers. Now, it's going up. Why is it not going up? Can you help me? Oh, okay, all right, now it's playing tricks with me. Come on, come on, come on. Okay. We have started some time ago, okay? Because some of the people will go. All right. Now, the main advantages of using these reinforcements are that they can increase in the load carrying capacity because they are strong, reduction in the depth of the cracks or the material, reduced cost and low construction time. So these things can be done quite easily. This is where the fly ash can be used in the road construction. Now, typical material properties of selected fiber and matrix, that is worth remembering and knowing that. And pitch-based fibers has modulus of elasticity of about 830 GPa, which is pretty close to that of carbon. What is the modulus of elasticity of carbon? All right. Think about it. It can be 1000 GPa, something like that. Carbon can show pretty high modulus of elasticity. Now, Kevlar fiber has high strength and its low density. Then ultra high molecular weight polyethylene has density less than 1, but all of them have pretty high strength. Even cellulose have strength of about 1200 MPa. So this is why these fibers are quite useful. The matrix, you can have epoxies. These are the ceramic or the thermoset matrix. You can have epoxies, 40 to 40, 85 is the modulus of elasticity. No. Okay. So this is the strength. Modulus of elasticity is coming here, 2 to 5 GPa. Polyesters 1.3 to 4.5. And the strength is here. Strength is, epoxy is about 40 to 85 MPa. Polyesters can be at 45 to 85. Some epoxies can have strength even up to about 100 MPa. Vinyl ester is the other one, which is the latest innovation over past 30, 40 years, and which actually used much more than epoxies or polyesters because it is much easy to cure. So it has 60 to 70 MPa, but its modulus of elasticity is about 3 GPa. All right? So it matches the middle of the epoxy values. Now, properties controlled by interface bonding are the fracture energy and the fracture toughness, and interlaminar fracture energy also depends on the fabric type or the same volume fraction. So if you have the same volume fraction, the interlaminar fracture energy depends on the fabric type. And one of our studies several years earlier, we showed that if you have about 65 to 67% fiber, but coming in different terms of fabrics, so different types of fabrics. So 65 to 67% fiber, so that means 33 to 35% resin. So it was glass fiber in matrix, thermostatic matrix, and there it shows that one type of fabric gave about 4 times more fracture energy than the other ones. And that concept was, when it was published, that concept was welcomed by Boeing International, and now all this green, what is the type of plane, 787, they are actually using that kind of thing. So they selected several fabrics, and they found that one of the fabrics has about very high fracture energy. That means it can be much more lightweight. All right. So for the same lighter weight, it can generate much more toughness. And toughness is very important everywhere. For the same volume fraction, you can have higher interlaminar fracture energy. Now, if you take a look at this is known as atomic force microscopy. Atomic force microscopy has been a development over the past 15, 20 years. And we had a very interactive research with IIT Kharagpur under his scheme and Professor Anil K. Bhaumik. So he is in the rubber technologies section, and he was also, when IIT Patna opened, he was appointed there as the director of IIT Patna. So he was there for first 5 years. And some of his research students, about 4 to 5 of them, they came to my school, and we had atomic force microscopy, and actually their research generated the quantitative aspect of looking into this atomic force microscopy and how it can improve the properties of the material. So it generated some of those information. Now, and they used in polymer matrix composites. So you have polymer and matrix. So here, the volumetric thing, if you look at this, if you have carbon fiber, short carbon fiber in cement, the atomic force microscopy can give features like this. So these are the micron size, and here these are the spectrum, and here you can actually see that these are the fibers, and in between them some matrices, epoxy, in between the fiber epoxies are actually, the white things are the epoxy, and they are actually holding the fiber. They're stiffening the fibers. Okay, that was one picture. I've just put another picture also. Now, this is a contrast enhancement, and here what you see that this is in water at 60 degrees or 200 degrees C. The earlier picture was in calcium hydroxide solution at 60 degrees C for 200 days, and this shows the same fiber in water at 60 degrees for 200 days. Why do you put these things? Because if you put these structures in the bridges or construct technique, there will be a lot of water, and there can also be, like calcium hydroxide can be in one way, the water can be in the other way, and 60 degree temperature is quite possible if you have the bridges and things inside, and 200 days is nothing for a road surface, all right, or a structural surface. So this shows you can actually how the epoxy can diffuse or affect the construction, all right. Here the carbon fiber in the cement, we have put carbon fiber in the cement. So again, in between the carbon fibers, these are the carbon fibers, and you can actually see the cement particles, or these are not fly ash epoxies, but I just wanted to give you the information that you can put other additives. So atomic force microscopy can be very useful technique. Have any of you worked in atomic force microscopy? And after Professor Anil Bhaumik's research scholars went there, and then he actually set up atomic force microscopy in his department, Rubber Technology Center. So that was a very good, about 5 to 6 years interaction with him, okay? And we developed a range of journal papers, but also new techniques were there. And it shows that this atomic force microscopy can generate quantitative information, not just qualitative information. So I included a couple of those things here. So these two shots which you have seen, this atomic force microscopy study of short carbon fiber in cement to assess the interface bonding after immersing in calcium hydroxide separately and water separately for 200 days at 60 C. So that kind of work can be done. And this particular work we had presented in CONMAT, what is Construction Materials Conference, and it was organized by Civil Engineering in IIT Kharagpur in about, I think, 2003 or 2004. So from construction point of view, road construction and point of view, so you can actually use, you can do the study, because short mill carbon fiber can also be a reinforcing agent in cement. And then through the epoxy, you bond them, or other materials, you bond them, and one can do it. Now here, N. Gauripalan, he was a colleague, a professor in my university in civil engineering department. G. J.P. Cow, he was one of my former students. He was a materials engineer, and then he has become a civil engineer. Since he did this research, all people think he's a civil engineer, and he is a very high position. Okay? But it is good because he worked with the civil engineer. So that is an example that even if you have different background, but if you work with other engineering professions, you will have very good thing. And Ron Postle, he helped in the atomic force microscopy area, Dr. Ron Postle. So that work was presented at IIT Kharagpur, and that conference was chaired by another Bandyopadhyay, and his name is Professor Jonen Bandyopadhyay, Janendranath Bandyopadhyay, and he was a professor. He has taken retirement, but he still lives in IIT Kharagpur. Okay, I wanted you to see these slides, and thank you. Now you have, all right? Because remember this, atomic force microscopy, don't forget it. Thank you. So this shows that whatever you use, there are ways to look at things, and new technologies are there. And atomic force microscopy, you don't have to break or anything. You just put it in. There are different types of atomic force microscopy technique, and then use. There are about 3 to 4 ways of doing that. You have atomic force microscopy here, Professor Kaur? Okay, some of you, if you get a chance. So he's an expert also in atomic force microscopy. You can have a look into that, all right? Because it gives you certain new features which other techniques cannot do that. Now, going back to the use of fly ash in Nizamuddin Bridge Road embankment in New Delhi, which actually has been an example of utilizing of fly ash in concrete. It's about 2 meters long and a height of 8 meters in a flood zone. And it has shown that the use of fly ash can be very welcome in adverse condition. If you have a flood zone, means there will be a lot of water absorption and things like that. And this not only saved the top quality soil and used fly ash, it also saved about $300,000 in a total project of rupees 10 crores. So it saved about 14 to 15% of the cost because the fly ash is the waste material which is available. So even if you can save 14 to 15% in the cost in the production, and it gives very similar properties, fly ash will be is very welcome. Also, fly ash can be used as sub-base in pavement also. So where you have pavements and things like that, you can put fly ash as a sub-base so that it can take up the stress and strain. Because if you cannot take up the strain, then the pavement may crack. And once the pavement cracks, it will take a long time to fix them up. So if you put fly ash as a sub-base, then now when you use sub-base for road, you can use fly ash in two ways. So you can use fly ash with soil, and you can use fly ash as reinforced with fiber. Hoover et al. proved that soil fiber composites were more effective in improving California bearing ratio. So this is something which has come, which is a penetration test for evaluation of the mechanical strength of road subgrades and base course, values of sandy soil as compared to slate and clay soil. So what lot of use of fly ash have been in USA, and USA have a lot of unfortunate incidents of these storms, heavy rainwater, and also earthquakes. And those things actually tend to, if you have earthquakes, they tend to shake the bridge and they tend to crack all those things. So California, state of California, they became the leading state in USA in modifying the bridges with all these reinforcements and also modifying the roads with all these things. And then they came up with by using fly ash. Whereas people used to think that fly ash is a waste material. No, they found that fly ash is not a waste material. So fly ash has become a kind of engineering gold. And so CBR is a California bearing ratio. So it is worth looking into that when you have time. And it's a very good test for evaluation of mechanical strength of road subgrades and base course and values of sandy soil and compared to slate clay soil. What sandy soil means? Have you heard the name sandy soil? What does it do? When it rains, what does sand have? Sand have a lot of voids, okay? When it rains, the water goes through all those voids as far as down. It can go up to half a kilometer, 1 kilometer down. So that is one way. So it can happen. Now, on the other hand, if you have clay soil, that means water is there and the clay takes it up, it becomes softened, so the water does not go beyond. So it has both advantages and disadvantages. If there is no water on the top, the water goes, but that advantage is that then you can later on drill the water out and you can use for other applications. But the disadvantage is that the trees and the things, they do not get the water because it goes down half a kilometer, 1 kilometer, and not many roots that go down there. So everything has advantage and disadvantage. So you can use fly ash under situations where they create the advantages. Also, Kumar et al. When you go through this fly ash utilization, you will find there are a good number of Indian sources of research in fly ash recycling. And some of them, most of them are from India, quite a few of them are from other affiliated universities outside. They performed an experiment to find out the effect of addition of polypropylene fiber in fly ash as an additive, and different tests were carried out. So, and you can add those fiber reinforced polypropylene, you can also add them in other applications, because the polypropylene can take up some deformation, whereas the fibers will not deform otherwise, and it will give some ductility. Now coming towards the other aspect of use of fly ash, which is use of fly ash to remove trace elements from aqueous systems. That is quite something useful. So fly ash have ceramics and things like that, and in aqueous systems often there is a lot of impurities, also lot of health hazards. So this part is not about the road surface, but what happens if you have drinking water, the areas from where drinking water comes up, or even otherwise, if it needs to be used as a filler or filter, either way, what is the property that fly ash can provide? So these days, wherever you have a water filter, like here and things like that, all water comes through filter, AquaGuard and things like that, okay? Now, because in some cases, water is much better than in some other cases. So people try to use fly ash because it's a composition of ceramics. They try to use fly ash. Can be used to remove selected trace elements from the wastewater and industrial effluents and make it valuable. So this group, Sajwan and et al., they focused on two objectives. A, determine feasibility of using fly ash to remove zinc, copper, cadmium, chromium, lead, and manganese from aqueous medium by using mixed trace element solution, and also to obtain optimum condition for maximum removal of this element from the mixed trace element mixture. So by doing that, they used two types of fly ash. One was taken from the power plant by Port Wentworth zone, another was taken from McIntosh zone of Savannah. So all companies will have a number of power plants. Like the work which we did in Cement Australia, they had 5 power plants from where we had taken fly ashes, and we have used all of them, and you have seen today also the analysis and the advantages of those and some disadvantages of some others. Likewise, these people took fly ash from two sources. Both fly ashes are different in composition. PWW fly ash had higher carbon content, that means higher L, thank you, higher LY, and the other one had lower carbon content. The study showed that PWA, which higher carbon content, removed more trace elements than the other one which had lower content. Here you actually can see this removal of chromium. So this is the 100% line, and here so this is how it can show that you can actually, with more time, and you can get rid chromium removal, you can go to almost 100% after a certain number of days. Whereas copper removal, you can only get up to about 20% removal. So some of them, this is contact time, and the contact time in hours. So if you work for 8 to 10 years, The outlet water has 100% of the copper removed. Yes, so water coming in, and after, if it passes through that filter after about 8 hours, then you remove almost all of that.
Because the fly ash also contains some heavy metals. So we have to first of all arrest this all heavy metal present in it. After that, the water is passed through that, so that the removal of
Yes, yes, that's true.
We can also remove this heavy metal by porous system.
Yes.
This is a chamber. We place a fly ash based material, and the water is filled in it. And we have the water is contaminated water. We have taken the outlet water in different interval, like 1 hour, 2 hours, 3 hours, 7 hours, maximum 72 hours liters. And the outlet water we have stored different pH, pDH, and other parameters from the parameter relatively decreases from the initial concentration to outlet concentration. This is the setup we have done.
Thank you very much. So that supports this idea about your new work, your new model. Thank you. So thereby, if you see lead removal and manganese removal, lead is removed significantly, and the manganese percentage is quite small, but part of it is removed. Here the contact time is about 8 hours, but in some cases, like he said, you can go for 72 hours or so, depending on what kind of testing you use. So lead removal was the manganese removal. Now, copper removal, zinc removal, of these things are showing. Why did it disappear? Yes. And the earlier we had seen chromium removal, which can go up to about 100%. So this shows that fly ash, and as your colleague from Kate in Bhubaneswar shows that, so fly ash can actually be used as a filter to eliminate all these difficult elements from water, so it can be filtered. And this filtered water is everywhere, and that's also creating a lot of new business. Okay? And depending on the contents in the water, say for example, in some water sources, these contaminations are more. In some water sources, the contaminations are less. So one can use these different types and different percentage of this different contamination removed. But fly ash, this last presentation, I wanted to show that fly ash can also be used for that purpose. Often people think that fly ash is like unwantable components, but they have shown that no, the ceramics and the things which are there, they can actually, you can use it as a filter for removing the unwanted components in drinking water and water. So fly ash can become a health solution for the community. And because fly ash is cheap and it is readily available, you can do that. This figure shows removal of trace elements from aqueous solutions, and the source are Kenneth, then Sajuan, and Paramasivam, and quite a few people, say about 10, 12 years ago, and is published in Springer Science and Business Media. Now, Sajuan and team, they also observed that fly ash could effectively remove trace elements, but some factors such as concentration of adsorbate and contact time can affect the percentage removal. So like you said that, all right, you may have to use more time more time than 8 hours in certain cases. Okay, so that is quite possible. So everyone has to do experiments and go for the time which will remove all these contaminants. From the above figure, it can be concluded that for less adsorbate, which means trace element concentration, for example, 5 milligram per liter, which is quite small, PWWFF fly shows very good results and removes almost all the trace elements at contact times up to 8 hours. Whereas, if you have 50 milligram per liter adsorbent concentration, PWW fly ash removes significant amount of lead, but not other elements like magnesium, chromium, or copper. So our contact time should show some improvement to removal of cadmium and zirconium. So these things show that depending the fly ash, you can use it, but depending on the type of the contamination concentration, you have to select the combination of fly ash and also more time, which is because dissolution and removal and deposition is always a function of time, unless you increase the temperature. But if you increase the temperature, that might affect other things, and also it will be very cost bearing. And in between those two, which are a very high adsorbate concentration and the other one which has very low adsorbate concentration, if you go in between, which has 25 milligram per liter, some elements like lead, chromium and copper can be removed by using this one fly ash, which is high carbon fly ash at a constant time. So that means if you have high carbon fly ash, high LOI, that can also actually remove the lead and the thing. So if you have high LOI, it is all right for certain applications. Okay? So fly ash is a very useful material. Thus, it is also concluded that amount of removal of trace element increases with increase in contact time. So the more you leave the contact time, the more the removal of the trace elements will be there. So conclusions. Properties of fly ash, types of fly ash, bonding between fly ash and other materials. These are very important. And we have covered all those aspects in these 15 hours of lectures and the 5 hours of tutorials. And we have had discussion, interaction. So fly ash can be a very valuable material. Class C fly ash, where the calcium content is high in the range of 20 to 28%. Class F fly ash, where the calcium content is low, generally 1 to 12%. And there can be other elements in the fly ash, in some particular fly ash like AS, MO, U, and Zn. Now, the benefits of application of fly ash in concrete is a very valuable area, and there is no end to increase this application. It reduces addition of fly ash in concrete, reduces amount of free lime, and also affect these properties given below. So these improvement of the concrete properties are: it decreases permeability, fly ash improves strength and ductive durability, because fly ash is like a reinforcement. Now, we say that this is spherical reinforcement, but as I have shown, a lot of reinforcements are very small. In fact, that atomic force microscopy pictures which I have shown you, that those carbon particles, they are not continuous carbon particles. They are just short-mailed carbon particles. But even then, they provide toughness and strength there. All right? So if carbon particle bonds with cement, and then if you use other polymer things, so they bond the carbon particles. So those carbon particles which you saw in the atomic force microscopy, they are not continuous. They are all small, very short length carbon particles. So fly ash also, in some cases, can almost reach that dimensional limit. So fly ash improves the workability, improves chemical resistance, and reduces the heat of hydration. So in the concrete structure, fly ash gives these 5 distinct improvements. Decreased permeability, improves strength and durability, improves workability, improves chemical resistance, and reduces heat of hydration. Now in bricks, this is how we started, and we have also seen in earlier chapters. Fly ash shows resemblance with brick clay in physicochemical properties. So whatever the brick clays or clays which make the bricks have, fly ash has similar resemblance. So also being used in manufacturing bricks, and shows advantages as follows. So the fly ash in bricks, flexibility in factory location, that means easy availability and persistence, no pre-processing, no faster addition. So the only way it will help if you have the fly ash and the brick, fly ash manufacturing and the brick next to each other, or that way a lot of fly ash companies can also generate brick companies. Okay, so the brick companies will have fly ash from the power companies, so you can use it. Higher on average 25%, 24% more compressive strength as compared to conventional clay bricks and other standards. So if you make fly ash bricks, they can be even stronger than fly ash. They can also be lighter than conventional bricks. So you can take more bricks over time. And it shows lesser cracking than conventional bricks because of 3 times tensile strength. So it can stand up load about 3 times more before any cracks generate. Okay, so fly ash bricks are also applicable and advantageous. Not only that, you can also use more loading floors, and then you can also, because of transportation and construction with low transportation costs because of low density of fly ash, so it is quite attractive. Improved strength of structure, which becomes possible because of optimum IRA and the steady state absorption rate of fly ash, and good surface attack and durability. So these are the advantages of fly ash. And then environmental benefits also are important. And now coming to the stage of mortar, how fly ash can replace cement in mortar. So fly ash can replace bricks and other things in clay, but also fly ash can replace cement in mortar because of pozzolanic. And pozzolanic means water absorption. Pozzolanic and physical properties, and shows better fluidity and less water demand, and increases the function of water demand ratio by fly ash. So you have to take a flying plane, fly ash to flying plane. Okay, thank you. Good. If you can stay for 30 more seconds, we'll finish this one, or 1 minute. Thank you. Now, in agriculture, fly ash is proved to be beneficial material in agriculture field as it improves physical and chemical properties of degraded soil by treating as soil, ameliorate and increase the yield of crops. Why? So if you put fly ash there, it gives more presence of vital elements like potassium, sodium, zinc, calcium, magnesium, and iron. So all these are valuable for your health. And fly ash enhances soil properties such as fertility, soil enzymability, activities. Now coming closer to the end, road construction. Instead of using aggregate construction like soil, stone aggregates, stone chips, sand and cement in the embankment, the granular sub-base, water-found macadam, and all these things, if you put fly ash, they show better results with low cost. Removing trace element is useful. Fly ash proves successful to remove trace elements. For example, all these elements, zinc, copper, cadmium, chrome, from aqueous solutions, and having fly ash, having a high carbon content proves more effective, because if you have high, they actually soak up all these materials. So environmental benefit of using fly ash is improvement in land fertility, reduction in carbon dioxide emission, and energy cost, as well as cost savings. And with that, I say thank you all. Thank Professor Kamalkar to organize these things. And here the tutorial ends. I know that you have to leave. Some of you have to leave. So I'll hand it over to Professor Kamalkar.